You are great, my dear friend Mikkel. You are great. I finally found the answer. Mikkel, before even saying what the answer is, Albert continues. And when I ask if we agree that two events happening at the same time are simultaneous, Mikkel replies, well, of course. This is a big mistake. Now think about it with me. We are on the edge of a ghost railway. There are two electric poles, and we know the distance between them. Let's find the middle of them and mark it right in the middle. You stop. Take a mirror in your hand. These are two. Let lightning strike at the same time. When I look through this mirror, you will see that both events are happening simultaneously. Now get on a train that will pass through here. Have a mirror in your hand that shows both sides. When the train reaches the point we marked, let lightning fall on these two poles again. Will these two lightning strikes occur at the same time? While Mikkel is thinking, this is Albert's answer. No, of course not. When I look through the mirror, I first see the lightning in the direction of the train. You will see the lightning falling because it takes time for the light to travel from the pole to the mirror. In the meantime, since the train will travel a little further, the light coming from the pole behind will also travel a greater distance. You will see it as if it fell first on one and then on the other. For someone traveling on the train, these lightning strikes appear as if there was a delay in between. For someone standing on the edge of the rails, it will seem like they fell at the same time. But that's when Mikkel intervened. He said, yes, take time, my dear friend Mikkel. Time is relative. We say it looks like a spark. Sometimes everything turns into a big fire burning in the mind, and sometimes it's just a subtle change. If you change, you are no longer the old you. Sometimes this fire spreads to all minds. Nobody is the same anymore. The world is not the same anymore. Was it Albert's spark? This train track thought experiment, that enlightenment that changed everything. Take it from here. The story continues. These types of thought experiments, this thought, aren't they a very simple deduction? Now, it seems so. He also mentioned that there is nothing unusual, illogical, or mysterious here. He is simply trying to express that time flows at different speeds for all of us, but he is having a hard time understanding why everyone grasps it as something so straightforward. Only 5 weeks have passed since this deduction. Afterward, he wrote an article with all the evidence and even put it on paper. We know the result as the special theory of relativity. In its simplest form, the faster you accelerate, time will flow more slowly for you than for an observer standing still. He will discuss the reflections of this in his article. Take one clock to the equator and place the other at one of the poles. He said that the clock at the equator will run slower than the clock at the pole. He made this statement in 1905. This is the simplest interpretation of what he said, no matter how challenging it may be to grasp while on the way to work. Time passes more slowly when you sit at your desk. Of course, for a car traveling at a speed of 100 kilometers, it is not possible to perceive this because the change in time is incredibly small. However, for example, the car you drive to work or the metrobus you take can reach 90% of the speed of light. Then, Sadie observes very strange things. The sea, for example. Your height would appear 40% shorter than normal to someone looking from the roadside. The answer to the question he asked when he was 15 was revealed here. What would happen if we knew that a light wave was traveling? The answer is nothing. Yes, it would be nothing, because when you reach the speed of light, your height will be compressed, and time will stop for you. Even if something is happening, you cannot observe it anyway. Of course, this was considered crazy by everyone at that time. Take it out, it was a bit crazy. They called it unprovable crazy nonsense. But every time we looked at it from then on, it was such a beautiful theory that worked, just as he said. This is how the theory of special relativity was discovered. He sent it to the magazine Annalen der Physik with the title, On the Electrodynamics of Two Moving Bodies. But in the article, there was no reference to previous works or any mention of anyone else. He only thanked his close friend Mikkel Faith, soy for patiently listening. Above all, he even mentioned his wife in any way, even about the national weather. From time to time, researchers talk about their spouses and families as an expression of love or out of respect. But as can be understood from Einstein's letters, it seems that there was an exchange of ideas between them about light and motion problems. Then why did he mention Leva? Wasn't it some source? Leva's contribution to these theories was significant. The listener is the one who understands what he is saying and can comment on it, but ultimately, he is just a listener. As you may recall from the previous video, I was not in a position to spare time for intellectual discussions. He is an extremely ambitious character who sees it as unnecessary, but we can see this ambition in his works and the interest he shows in his studies. If you ask whether his theories go beyond the realm of time, I would say they do. In fact, in 1905, which we know as the Annus Mirabilis, that is the miracle year, he revolutionized our understanding of light. Was the quantum theory putting forward ideas about the particle properties of light and the existence of the atom? Yes, so that you can picture it better in your mind, we are talking about a period when even the existence of the atom was doubted. In times when anti-science was much stronger than today. Anyway, while the ideas were following each other, special relativity, mass and energy, when applied, would give rise to one of the most important formulas in history, E(m)(2). In other words, the amount of energy present in an object is equal to its mass multiplied by the square of the speed of light. We are talking about a staggering number. Albert himself expressed it as follows. Even a gram of matter contains an incredible amount of energy, but unless this energy is released, it cannot be observed. It's like something hidden. Imagine that it's an incredibly rich person. This man dresses ordinarily and doesn't spend much money. Otherwise, he is an ordinary person to anyone. You wouldn't know how much money or energy he has. A new patent office employee is now beyond his height, and his product is slowly starting to spread. Considering that he did not receive any payment for his theories, he still continued to work in the office. On the other hand, he was giving private lessons. Meanwhile, things that he was not accustomed to were happening. Professors from surrounding universities were coming to the patent office to see this young physicist and get to know him. They said they wanted to meet with Albert for an assistantship after graduation. He applied but did not even get an answer from the professors. He actually wasn't very aware of where these theories would lead. All he did was challenge his own thoughts, considering Yigit Ilmezli. What did he do first? Instead of setting aside bragging about the successes he had in the articles published in this miraculous year and resting for a while? Well, he realized the inadequacy of his theory. Yes, it was an excellent theory. Special relativity was working great. In 1907, while a special officer was reinterpreting it for another physics magazine, he suddenly stopped writing and realized something. His theory covered almost the entire physics of that time and could express many things without error, except for one thing: gravity. Under normal circumstances, very few people would dare to do this because gravity was established, and now it was working very well. Those irregularities will change everything except for a few small problems. But normally, if you put a kilo of iron on one side and a kilo of cotton on the other side, it balances the scale. Because the mass of the world affects both of them equally, but that's where the problem was. How was the world doing this? I mean, iron or cotton, how did I feel this power of the world? Forget about this force. He said that it was governing in the solar system. the satellites of the celestial bodies. He said it was a law. Oh, forget how gravity is effective throughout the entire universe. This is clear. How the force controls the entire universe, and the whole mystery was here. How do all the planets follow a certain route? What provided such an order in the universe? I want to know the way of thinking of God, he said. Aldermach. Not clear. What did slang say? Once upon a time, take it here. Do you know you are playing the biggest gamble of your life? He said, don't touch it. Max, like Albert, touched gravity. You can't solve it. Even if you do, no one will believe it. It's a very complex, very difficult problem. No one has even called it courage for centuries. Stay away from it. Al was aware of it here. In fact, we knew it would be very difficult, but once again, special relativity. Actually, he compared it to buying a child's toy. My head feels like it's going to explode. I've never been this challenged, he said. The biggest problem was that gravity is the most democratic phenomenon in the universe. Yes, all kinds of objects, everything from you and me to a fly, a neutron star, or a galaxy. Everything is the same for it, no matter what its material is, no matter how big it is. Gravity treats everything equally. So, here you go. Bertinelli is the starting point he can take. There is no exception he can make. No matter what he does, he didn't know how to approach this problem until the other diarist Camille Nestlé from the Aegean said, I think Albert was the happiest thought of my life. He suddenly gave a clear idea in his mind, with a thought experiment where he could look at God's way of thinking from a brand new window, and the answer emerged spontaneously. A historian of modern physics, and the editor of the book, The Collected Papers of Albert Einstein, Martin Sklein, said in an interview that if you could go back in time and ask Albert Einstein a question, we would ask this. How can you be so sure about the principles on which he bases his theories? How could I understand that the law of relativity is so universal, at every point in the fabric of the universe? How can you be sure that it works like this? According to him, it was really like that. The theory suddenly appeared, like the compass his father gave him at the age of 45. In fact, he constantly worked on problems in his mind, the issues he contemplated without a pause, and the moments of enlightenment he experienced. It was the result of decades of mental work. While everyone approached with skepticism, all the solutions he was confident in worked flawlessly, and continue to work even though more than a century has passed. But of course, we need to talk about the happiest thought of his life first. The Albert story continues, and as always, until we meet again. I hope you liked the video. Don't forget to subscribe and like the video. See you in the next one.